Assalamualaikum and good morning to all lecturers and panel, Dr. Nur Hafiz and Dr. Nur Zawani. Today, I would like to present about my research. First, I would like to introduce myself. My name is Nur Helmi bin Nur Azri, matrix number B011710072. I would like to thank to our supervisor, Dr. Fani bin Sulaiman, that contributes and guides for this research. Okay, the title of my research is the optimal load management strategy among residential consumers in South Peninsular Malaysia. The presentation is divided into 4 chapters. The slide will start by explaining the introduction, literature review, methodology, and the research result. At the end of this slide, I will share the research conclusion and future recommendation for this research. Chapter 1, Introduction. Okay, what is the problem that we need to solve in this research? The project scope is about residential consumer problem. The three main problem is increasing of consumer electricity bills, high energy consumption, and the consumer have no choice in choosing their tariff program. Okay, for research objective, the objective is obtained from the problem statement. The aims of the research is propose new demand response, reduce the electricity cost, and lastly, to compare the performance of proposed optimization algorithms. Chapter 2, Literature Review. In this chapter, I studied the previous literature that have been done by previous researchers that related in this study. All the information is based on IEEE and Science Direct database. The important key is such as demand side management, demand response, price-based program, time of use tariff, advanced metering infrastructure, and end colony optimization. The advanced metering infrastructure is generally a smart metering device. The device can store the energy data and can be utilized by both consumer and the energy provider. The data from the meter is obtained as a load profile sample in this research. In Malaysia, the installation of smart meter is still not comprehensive to all residential. Next is about demand response. What is demand response? Basically, demand response is change in the power consumption of an electric utility customer to better match the demand for power with the energy provider. So, what is the function of demand response? It will provide the tariff program for better energy policy. Basically, two main categories is price-based program and incentive-based program. There are many programs under these two categories, but I am focusing on TOU and flat tariff. The difference between these two programs is TOU has two or more cost rate depend on its zone, while the flat tariff is cost is constant. Okay, with the load profile sample, we must set a strategy to reduce the electricity cost. There is 6 types of DSM strategy that can be proposed, but I am focusing on load shifting method. This method is about shifting the high energy consumption to the off-peak zone that have cheaper cost rate. The important factor is what appliance that can be shift and how many percent load is suitable to shift. Next, to prove the benefit of my tariff design, an optimization algorithm is needed. The optimization algorithm is an algorithm with procedure which execute iteratively by comparing various solutions till obtain the optimum solution. The end colony optimization is chosen in this research. The end will find the best parameter of each energy consumption that's suitable to be shifted, so the price of electricity can be reduced. Chapter 3, Methodology. This result will show how is this research flow to get the result. First, what is the equipment needed in this research? We need the computer device. I am advising using a better device with good processor to avoid damaging the computer because the SEO simulation uses high data flow. Next, the simulation software is needed is MATLAB. By using M5 script, we can simulate the complex SEO algorithm. Please use the full version for better results. Next, we need the MyTMB account. From the account, you can download the energy consumption data as a sample. Please ask a permission from the owner first. Next is what the important parameter that we needed in this research. First, the tariff must be designed properly according to the load sample profile. The rate and the time zone is chosen. Next is the energy load profile parameter. This is obtained from the MyTMB data that have been downloaded before. Next is the SEO parameter. The alpha, beta, rho and the number of iteration is defined as constant. What is need to be varied is the load shifting weight percentage. The research flow is starting from defining the variables such as load profile, TOU rate, flat rate, time zone, and all the data is saved in load profile code. Next, for simulation process, the SEO also be set first of the variable that I have explained before. The SEO will simulate the data until the max iteration that have been set. At last iteration, the best output will be represented in the program. Chapter 4, Result. This chapter will present the output obtained from the simulation process. First, the program will give the output in the command window form and visualized form. The parameter is the TOU cost, flat rate cost, and the total saving percentage. The graphic form is the end fitness vs number of iteration graph and baseline load profile with the best shifted load profile that have been proposed by the end colony optimization. As you can see from the figure, the dotted line is the proposed load profile and the straight line is the origin load, or called as baseline load profile. The results show that the peak consumption is shifted into the off-peak zone with the factor of shifting weight percentage. Okay, this is the best load profile that have been proposed by the SEO program when shifted load is set at max 30% that have been suggested by my supervisor. Next, what about the optimization algorithm performance in this PSM application? So, I compare the end fitness of various data with the same number of iteration. The graph shown that the shape of the end fitness is very stable, so the program is run in 2 stages. So, the data obtained is reliable. Next, the important result in this research is how about the cost reduction that can we make? From 5 different simulations, it shown that the electricity cost is reduced simultaneously to the percentage of load shifting weight. The best percentage of cost reduction is 13.43%, and the minimum we can get without shifting the load is 7.84%. So, the result achieved the main objective of the research. So, I can conclude that TOU tariff can offer electricity cost reduction with suitable tariff design. Next, the load management also contribute in reducing in the electricity cost. For future works recommendation, I suggest by enhancing the TOU tariff design for better result. Also, I hope after full installation of smart grid in Malaysia, the energy provider give the option to the residential consumer to choose their tariff program, such as TOU tariff. Okay, that is the end of my presentation. Thank you for listening. I would like to thank to UTEM that provide me with the database for my study research. I am also thanks to my supervisor, Dr. Fani bin Sulaiman, for helping and guiding me in my research. Here, I attach my phone number and email if you have any question. Okay, that's all. Assalamualaikum. Stay safe and stay at home. Thank you.